Derived from the diet or from the structural component of the bone, calcium ions is very important in the normal body functioning. For example, it is a key element in the normal blood clotting process, in the signal transduction, and also to maintain the membrane potential of the cells, etc. Similar to blood glucose level, human body also needs to control the calcium level. The homeostasis of calcium level is maintained by several hormones. In this episode, Professor Chen will talk about the hormones that regulate the calcium level. He will also introduce a bone disease called osteoporosis. Welcome back, Professor Chen.
Hi, Patrick.
Now, I'm going to talk about the small molecules called calcium this time.
Yeah.
Now, as we know, like the glucose level, we also have to control the level of calcium.
Yes.
So would you please tell us how is the homeostasis of calcium is maintained in our body?
You know, calcium is an essential element we need in our body. The daily recommended intakes are from less than 500 milligram in baby to 1,000 milligram in children, or more than 1,000 milligram, like 1,300 milligram for adolescents or pregnant mother. Around 1,000 milligram or 1 gram for adults like us. Inside the cells, we need calcium for cellular signaling. It's a signaling molecule, and in our body, we also need calcium to make up bones to support our body. So again, homeostasis is the key word here. In this video, we shall learn about the details of calcium homeostasis, following with the 3 hormones, vitamin D, parathyroid hormone, and calcitonin, one by one. At the end, we discuss osteoporosis and its treatments. First, this diagram shows the dynamic changes of calcium in our body. On average, we have over 1,000 milligrams of calcium entering our body and circulating around our body with 900 milligrams in the blood. Using phosphate as a counter ion, around 500 milligrams exchanging to the bones, over 5,000 milligrams of calcium passing over the kidney, around 800 milligram of calcium being excreted out of our body.
Professor Chen, you mentioned quite a number of numbers regarding the level of calcium. Well, I guess this is regulated by certain molecules. Would you please tell us, are there any molecules like hormones that could regulate these numbers?
Yes, exactly. The hormones involved are mainly vitamin D3, made from cholesterol, being metabolized to its active form of calcitrol, which controls calcium uptake from the gut. Parathyroid hormone from the parathyroid glands also controls the formation of calcitrol, the active form of vitamin D3, and calcium release from the bone. A hormone from the thyroid gland called calcitonin is counteracting the effects of parathyroid hormone, PTH.
Now we know that vitamin D3 is important in the bone formation. Would you please tell us how exactly is the bone formed in our body?
Oh, actually, bone formation is a complicated process. Let's have a look. Vitamin D3 and PTH inducing the first step of bone formation by removing the cover layer of osteoclast. After macrophages further remove the top layer, osteoblasts will add on, forming the bone surface to fill the cavity. Osteoid is further mineralized, and the bone surface is formed again.
I'm also interested to know why vitamin D is regarded as a hormone. I suppose this is a very small molecule, and how exactly this is produced in our body.
So your question is why vitamin D is a hormone? Because we made it from our skin, and only 10% is obtained from foods. And sunlight converts cholesterol to precursors, and they don't dissolve in water. Let's take a look at the metabolism of vitamin D. 25 hydroxylase in the liver can convert the precursor to vitamin D3, and the active form is actually converted to 125 vitamin 3 in the kidney by another hydroxylase, and this step is induced by PTH.
Professor Chan, now we know that vitamin D3 is important for the bone formation. I'm also interested to know, are there any other actions of this vitamin D3 in our body?
Okay, the actions of vitamin D3 is to increase calcium levels in the blood. Let's take a look at this slide. The actions of vitamin D3 is to increase calcium level in the blood circulation by mobilizing calcium from mature bone, increase bone restoration on osteoblasts, increase calcium reabsorption in the bone, and promote mineralization, intestinal uptake from intestine, and renal uptake of calcium. It can reduce the PTH levels too.
Now let's talk about another type of hormone called parathyroid hormone. How does it regulate the calcium ions?
Parathyroid hormone, or PTH, can be regarded as a hormone in controlling calcium ions in blood circulation. When blood calcium is low, PTH is released from the parathyroid gland. Its job is to increase bone release of calcium and intestinal uptake of calcium. PTH also reduces calcium loss in kidney, but it also promotes phosphate release into the urine.
Now we know that PTH controls the calcium level, and the calcium level is related to calcification. So I would wish to know how is the PTH level is related to the calcification?
Yeah, for the job of calcium homeostasis to be done perfectly, calcium is to be controlled in a narrow range. Calcium levels in extracellular fluids have a negative relationship with PTH levels in the blood. At high PTH, calcium deposition occurs from the bone for calcification. However, low PTH levels promote calcium phosphate uptakes in the bone for bone formation. At high PTH, calcium deposition occurs from the bone for calcification. However, low PTH levels block calcium phosphate uptakes in the bone for bone formation, hence also contributing to calcification to a certain extent.
Professor Chan, how do hormones regulate mineralization of bone?
Okay. Estradiol and calcitonin are also involved in controlling demineralization and mineralization of our bone. While vitamin D3 and PTH are required to initiate the process of turning on bone formation, they turn on a protein called RANK, RANK, or receptor activator of NF-kappa B. This process alone is demineralization in getting the calcium out from the bone. However, estrogen can inhibit this process. Of course, vitamin D3 facilitates bone formation and bone surface formation. Calcitonin also inhibits the process of forming RANK and RANKL on osteoclasts, with a net effect of blocking the initiation of bone formation. In other words, estrogen facilitates bone retention of calcium. Calcitonin can help in keeping calcium in our bone.
Professor Chan, we know that some hormones have counteracting actions, like the insulin and glucagon from the pancreas. So do we also produce some hormones that have a counteracting actions to the PTH?
Yes. Calcitonin is a hormone from the thyroid gland to counteract the effects of PTH by reducing calcium release from the bone. Calcitonin and PTH work in cohort to control blood calcium levels. In other words, calcium can be stored in the bone, and PTH can get calcium out from our bone to the blood and travel to other tissues in need of calcium.
Now finally, I wish to know if the regulations of the calcium level has any problems, what will be result in our body?
Okay, with the above concepts of calcium homeostasis as controlled by hormones. One key application of such knowledge is to help patients with osteoporosis. There are two types of osteoporosis. Type 1 is bone density decreased in post-menopausal osteoporosis. Type 2 is senile osteoporosis in patients who do not have enough vitamin D3 or PTH. Normally, vitamin-fortified milk or in supplements will be useful. However, some type 1 osteoporosis patients are recommended to take estrogen therapy. Even this could be risky in promoting cancer. Alternatively, calcitonin could be considered to prevent calcium loss from bone. You may like to write a short review paper on the use of calcitonin as a drug for treatment of osteoporosis. Recently, a new drug called Prolia, which inhibits RANKL to bind to RANK, is also recently being developed for osteoporosis treatment.
Thank you, Professor Chen, for telling us the osteoporosis and its possible treatment.
Okay, you're most welcome.
In this episode, we'll learn about the functions of parathyroid hormone, calcitonin, and also vitamin D3. These are the three major hormones that regulate these calcium ions. Because of the importance of calcium, research work related to the homeostasis of calcium is still actively researched in the scientific community. As a biochemistry student, are you also interested in joining this fantastic research work?